everyone. Hello students. My name is Munda. Social Study Lessons for Grade 8. I'm ready to present each topic with a short and please invite your friends. Don't forget subscribing this channel. We will discuss some important points from your textbook. The Grade 8 Social Study textbook contains 7 chapters, and the first chapter deals with the physical characteristics of the Earth. So we will see the physical characteristics of the Earth under Unit 1. Now let us start the first lesson. It's about the physical characteristics of the Earth. So when we talk about the physical characteristics of the Earth, we are talking about the physical environment of the Earth. So the physical environment of the Earth is not in a static state. It is dynamic. It changes from time to time. This means it is in continuous change. The environment is in continuous change. That is not static. There are many factors which changes the surface of the earth, what we call forces and agents. Many forces and agents create the change on the surface of the earth. So we are going to see these forces and agents which are factors of changing the surface of the earth. Forces shaping the earth's surface. So our today's lesson is forces shaping the earth's surface. So here we have objectives. After studying this lesson, you will be able to 1. Describe internal forces shaping the surface of the earth, and 2. Identify landforms created by internal forces. So after completing this lesson, after studying this lesson, you are expected to describe internal forces. Those are shaping the surface of the earth, and also identify landforms created by these forces, what we call internal forces. Internal forces and resultant landforms. So we are going to see these internal forces and the outcome of these internal forces. First of all, let us define what meant by internal force. Internal forces are forces that come from the inside of the earth. So these forces are forces driven energy from the interior part of earth's surface. So they are from the inner part of earth's surface, and they can change the external part of the earth. By the way, the forces that can change the surface of the earth can be divided into two. The first one is known as internal force. It is also known as endogenic forces. This endogenic or internal forces can change the surface of the earth by creating ups and downs. So these forces form ups and downs. They can form ups and downs on the surface of the crust. So because of the presence of forces which can cause ups and downs, that they can change the surface of the earth. The environment can be influenced by these forces. These forces include folding, faulting, volcanism, and earthquake. So internal forces internal forces are folding, faulting, volcanism, and earthquake. So let us see these forces one by one. First one is folding. So let us define what mean by folding. Folding is the bending of rock layer due to earth movements from one or two sides. So folding is bending of rock layer. Folding is simply bending of rock layers because of the movement of earth. The movement may be from one side or it may be from two sides. So because of the presence of movement of the earth, the earth's surface or the rock layer can be bending upward or downward. So this bending or folding occurs when two forces act towards each other. When two forces when two forces act towards each other, or when two different forces act toward each other on a given point, they form a pressure. They make a pressure on a given point. These forces acting from the opposite sides on a given surface. So, due to this force, due to these opposite forces, what I mean by forces comes from a different direction on a given point, rock layers are bent into folds. So because of the presence of these forces, rock layers are bent into folds. The process of folding is the result of compressional force. So when forces when forces applied on a given point, and they cause a given area to bend. So this bending is the result of what? Compressional force. The result of compressional force. Why? Because these forces are act towards each other from uh, uh, opposite sides. That is compressional force. And folds are most visible in rocks that contain layering. Rocks, a type of rock which contains layer, is known as sedimentary rock. So sedimentary rocks are a type of rocks, those of layers, and folds are most visible in rock which contains layering, means in sedimentary rock types. So folding is simply uh, bending. Folding is bending. Okay. There are different types of folding. One of the type of folding is known as monocline fold. Monocline fold. Monocline fold is a type of fold in which all rock layers bend in the same direction. If the rock bends in the same direction. If the rock bends in the same direction, the bending or the folding is known as monocline fold. It is known as monocline fold. Another folding type is uh, upward bending, when the rock layer bends upward. If the rock layer bends upward, the folding is known as anticline fold. Anticline folding. Therefore, this is one of the type of folding, bending upward or anticline fold. Another fold type is the opposite of anticline fold, which is known as syncline. Syncline folding is a type of folding which is created when the rock bend down. When the rock bend down, it forms a fold which is known as syncline fold. Syncline fold. So syncline is downward bending, while anticline fold is upward bending. Another point here, what I wanted to tell you is that the sides of a fold are called limbs. When fold created, it also has sides. The sides of a fold is called limbs. So limb is side of fold. Limb is side of fold. Side of fold. Results of folding are the formation of different fold mountains. So the result or the outcome of different types of folding is the formation of folding mountains. So there are different folding mountains in the world. Here we have a figure. So from this figure, we can understand the difference between upward folding and downward folding. Upward folding is known as anticline folding. Look at this figure, for example. Here, there is upward folding, this area. This is upward folding, and this area is known as anticline folding. This area, upward bending. This rock layer bends upward, and this region is known as anticline folding. Another point is syncline. Syncline, for example, look this area, syncline. The rock layer sink down and makes syncline fold. For example, this area we have syncline, and this area it is visible syncline fold. This is syncline. This area is syncline, and this area is anticline, upward folding. So we can understand from this figure the difference between anticline fold and syncline fold. And also you can understand one thing from this figure. Here is a row which indicates the direction of force. Here is a force which runs towards the center. Again, here is a force, another force, which runs towards a center. So these two forces come together and make pressure on a given point. This pressure is known as compressional force. This pressure is known as compressional force. So, compressional force is formed due to the presence of two different forces, and these two different forces applied on a point and make compression. Okay. Uh, as I told you before, and then the outcome of folding is fold mountain. Fold mountain. So let us discuss on the fold mountains. Fold mountains are formed by crust which has been uplifted. So fold mountains are a type of mountains. Those are formed when the crust uplifted, when the crust uplifted from the internal part towards the surface of the land. So it is formed because of the presence of internal force, which pulls upward, and what we call the anticline fold. So folded by uh, compressional force. It is the result of compressional force and upward folding. Fold mountains are usually formed from the sedimentary rocks and are usually found along they are found along edges of continents. This is because the thickest deposits of sedimentary rock are generally accumulated along the edges of continents. This type of um, rocks are found along the edge of continents, and the fold mountains are also found along the edge of continents. There are many fold mountains in the world. Actually, they are divided into two. Fold mountains are divided into two. What we call young fold mountain and old fold mountains. Now, here we have several examples. For example, Andes. Andes is one of the typical example of fold mountain, which is found in South America. It is found in South America. And another example is Rockies. Rockies located in North America. It is located in North America, around here. And Alps are found in Europe, Himalayas, Asia. Himalaya is found in Asia. Atlas, North Africa. Atlas, North Africa. North Africa. Cape Range, South Africa. Cape Range, South Africa. And Australian Alps found in Australia. Australia, around the So these are the seven major fold mountains. Those are found in different parts of the world. Uh, this process of mountain building, are called orogeny or orogenesis. Orogeny or orogenesis. So orogenesis is the process of mountain building. The process of mountain building is known as orogenesis or orogeny. The plane, another point, what we have, we should see is axial plane, a plane that splits the fold into two halves, splits splits it into two halves. The plane that splits the fold into two halves or marks the center of the fold is called axial plane. So axial plane is a plane that divides folds into equal into two equal parts. Another point is a line which marks where the axial plane intersects the surface of Earth is called hinge line. Hinge line. This one is axial plane. Axial plane divides fold into two equal parts, and a line which divides or intersects the surface of the earth is known as hinge line. Another point, the areas on either side of curved hinge zone stick out like arms. Curved hinge zone. Curved hinge zone stick out like arms or legs are called limbs. So let us see these 3 points from figure. Here is a figure. So from this figure, we can understand 3 main points: axial plane, hinge line, and the limbs. So this is axial plane. This is axial plane. Axial plane is a plane. Axial plane is a plane which divides the fold into two halves. And hinge line is a line which marks the folds just like this. And limb is limb. Limb is a place which is which looks like a stick out like arms or legs. Curved hinge zone. It is a curved hinge zone. Limb is a curved hinge zone. This is hinge line, and this is curved hinge. Curved hinge zone is known as limbs. These 3 points are very important pointers, and you can identify by referring these kinds of figures. And also this figure can illustrate the anticoline fold and syncline folds. Here there is anticoline fold, which is known as upward folding. Here again we have upward folding, what we call anticoline fold. And around this area what we see is syncline fold. Okay. Another point is faulting. What we have seen till now is folding, So folding is one of the internal force which influences the external part of land surface. Another internal force is faulting. So now let us discuss what I mean by faulting. Movements in the crust, movements in the crust of the earth sometimes make crack. So there is movement in the earth crust, and this movement is sometimes makes cracks, sometimes makes folding. If the movement of if the internal movement of uh, um, forces makes cracks, it is known as faulting. So faulting is cracking. These cracks are called faults. These cracks are called faults. Cracks happen because of the presence of uh, internal force movements. Faults occur due to two basic forces. So there are two basic forces that can create faults. These are tensional and compressional forces. Tensional and compressional forces. Okay, these forces are the two basic forces which can make faults or cracks on a given area. Tension forces tension forces cause a normal fault. Tension causes normal fault, and the compressional force causes reverse fault. So tension, normal fault, compression, reverse fault. So you can understand the difference between these forces. If tensional force applied, the outcome is normal fault, and if compressional force applied, the outcome is reverse fault. Okay, we do have figure here. This enables us to identify compressional force and tensional force. Here we have compressional force, and this is tensional force. So from this figure, you can understand the difference between compressional force and tensional force. During a compressional force, there are two forces applying on a given area from different sides. So these forces applied on a point which is found between the two forces. So when this force pushes toward this one, this is pushing toward this, and this is pushing toward this, and they are pushing toward each other. They are pushing toward each other and makes compressional force. This time, the outcome will be a reverse fault. Reverse fault. The one comes under and another comes over the other. This is due to the presence of a compressional force. So compressional force make reverse fault, while tensional force makes normal fault. Normal fault. Okay. Again, here we have two forces. This force, they are acting against each other. these forces acting against each other, and the outcome is normal fault. This is a normal fault, while this one is a reverse fault. So compressional force produces reverse fault, while tensional force produces normal fault. So the difference between the two is clear. Okay, there are two major landforms that can be formed as a result of faulting. So when um, different forces applied on a given area, uh, two types of landforms are formed. These are Rift Valley and Block Mountains. Rift Valley and Block Mountains. Now let us see one by one. Rift Valley system. What is Rift Valley? It is a linear-shaped lowland area. Rift Valley is simply linear-shaped. A linear-shaped lowland area. A linear-shaped, not only linear-shaped, but also a linear-shaped lowland area. Linear-shaped lowland area, which is found between highlands or mountain ranges. A linear-shaped lowland area found between highlands or mountain ranges. So Rift Valley is formed when land between two parallel faults sinks down. So Rift Valley is the result of sinking. The result of sinking. Result of sinking. So when faulting happen on a given area, the outcome will be a sinking, either sinking or uplifting. If sinking happen, the landform created is known as a Rift Valley. So Rift Valley is formed as a result of sink down of landmass. When landmass sink down, the area will be called Rift Valley. Okay, the largest Rift Valley in the world is East Africa Rift Valley, which extends from Syria to Mozambique. It is about the total length of Rift Valley, Great East Africa Rift Valley, is about 7,200 kilometers, of which 5,600 kilometers is in Africa, and about 1,700 is in Eritrea and Ethiopia. The Ethiopia Rift Valley is part of the East Africa Rift Valley system. So East Africa Rift Valley also crosses Ethiopia from the northeastern Ethiopia towards southwestern Ethiopia, and it bisects Ethiopia into two diagonally. Okay, here we have a figure A and a figure B. So the difference between figure A, this is figure A, and this is figure B. So the difference between the two figures are visible. This is a flat surface, figure A. When you see this figure figure A is a flat surface. A flat surface. That means it is a flat surface before faulting. But after faulting, the result of faulting or the outcome of faulting is figure B. Figure B. Here the landmass sink down and the formed topography is known as Rift Valley. This is Rift Valley. This area is known as Rift Valley. This area is known as Rift Valley. Why? Because it sink down, uh, and makes the lowland area, which is found between highland areas. Here we have highland. This is highland. This is highland. Another here we have highland. A linear shaped, linear shaped, a linear, a linear shaped lowland area which is found between highland areas or mountains is known as Rift Valley. So this is Rift Valley. This region is known as Rift Valley. And the two sides of Rift Valley, here, this point and this point, are known as Forest Mountain or Block Mountain. Block Mountain. So, uh, Block Mountain is formed when the land surface is uplifted, and Rift Valley is formed when the land surface sink down. So here we have seen the feature of a block mountain, which is uplifted and has a flat surface on the top. And here we have seen a topography which is sink down. So from this figure, you can simply understand the outcome of faulting, the two types of landforms, what we call Rift Valley and the Block Mountain from this figure. Okay, as I tell you before, Rift Valley, Great East Africa Rift Valley, is the largest rift valley in the world. It extends from Syria to Mozambique. So, from Syria to Mozambique by crossing Red Sea, Eritrea, Djibouti, Ethiopia, and Congo, and extends to Mozambique. So it is the largest Rift Valley system in the world, what covers about 7,200 kilometers. Okay, Horst Mountain or Block Mountain. Block mountains are formed when land between two parallel faults is pushed upward or upward the upward movement of the land due to the pressure from inside the earth. The upward movement of the land or pushed upward process is because of the presence of the inside forces. If there are two parallel faults, if there are two parallel faults, the crystal block between them may either rise or uplifted to produce a block mountain, or fail or sink to produce Rift Valley. So when the internal force applied on a given area, it may cause uplifting or sinking. If the force applied downward, the land surface may sink and makes Rift Valley. If the land rise up, the topography will be block mountain. These mountains are found in many parts of the world. So block mountains are found in many parts of the world. For example, uh, the Afar Block Mountain in Ethiopia. Afar Block Mountain, which is found in Ethiopia, is a typical example for block mountain. Another example, Rwenzori, which is found in West Africa, are examples of block mountain or horse mountain. I think it is better to have a short summary here. Well, we have discussed on two major points. We are discussing on internal forces. Internal forces are forces driven from the inside part of Earth's surface, and internal forces are examples of internal forces are uh, faulting, volcanism, and earthquake. And today we have discussed on folding and faulting. So, folding is simply bending of rock layers, bending of rock layer. When the land surface bends either upward or downward, it is known as folding. So there are different types of folding. For example, we have seen monocline fold, what we call a monocline fold, when all rock layers bend in the same direction. If the rock layer bends in the same direction, we will find monocline fold. Another folding type, what we have seen is anticline fold. Anticline fold is upward bending, upward bending. And the result of anticline fold is the formation of fold mountain, formation of fold mountain. And syncline is another fold type, and syncline fold is downward bending. If the land bends downward, it is known as syncline fold. Another point what we have discussed on is limpus. Limp means the sides of a fold. The side of a fold is known as limp. Faulting. Faulting is another type of internal force which can cause land surface changes. So faulting is simply cracking. And Rift Valley. Rift Valley is linear shaped lowland area which is found between highlands. So this is a short summary of our today's lesson. And here we have 7 questions. Please try to answer this question. Give short answers for the following question. Question number one: what is internal force? So you are expected to define internal force. What is faulting? What is faulting? What are the causes for faulting? So you have to write the causes of faulting. You have to list down the causes of faulting, and also what is Rift Valley. We have already discussed on it, and you have to define what mean by Rift Valley, and formation of Rift Valley, how Rift Valleys are formed, how Rift Valleys are formed. So you are expected to explain the formation of Rift Valleys, and finally how block mountains are formed, formation of block mountains, the formation of block mountains. So please do this exercise, and try to have a short note on these areas. I think this much is enough for today. Thank you. We will meet in near future by having another video. Thank you so much. Don't forget subscribing this channel. Thank you. Bye bye.